Have you ever wondered about something that seems simple, yet is incredibly profound? Something we've perhaps never truly stopped to think deeply about. It's something you see every day, yet never question, because it seems too obvious, too ordinary. Try to imagine. You leave the city lights behind, look up at the sky on a clear night. Does that scene sound familiar to you? Then the night sky appears with countless twinkling stars, like tiny pinpricks on an endless black curtain, and the Milky Way stretching like a hazy, dusty river of light. It's a beautiful, inspiring sight, but also utterly perplexing when you start to think more deeply about it, isn't it? And this is what puzzles me, a question I think will make you ponder too. What makes it so dark? Seriously, let's take a moment to reflect on this right now. Modern science tells us that in our Milky Way galaxy alone, there are approximately 200 billion stars. A colossal number, 200 billion. Furthermore, billions of other galaxies exist beyond our Milky Way, extending in every direction to the very limits of the most powerful telescopes. The entire cosmos seems densely packed with stars, as if someone had thrown a handful of glittering sand into a giant room. And this is what keeps me thinking. If the universe is so full of stars, if every corner of the cosmos is a blazing ball of fire, then why, when I look up, are my eyes not blinded by light? What creates the darkness amidst countless stars? Let's think deeper together. Theoretically, every tiny point in the sky should be occupied by a star. Exactly. If I look in any direction and go straight far enough, have you ever wondered if our line of sight should eventually hit the surface of a star? It sounds obvious, doesn't it? That must happen, unlike standing in the middle of an infinitely dense forest. Because no matter where you cast your gaze, you'll always encounter a tree trunk, right? Yet, when I look up at the night sky, what strikes my eyes is darkness. A profound, pitch-black night with no escape, only punctuated by a few scattered tiny specks of light. Don't you find this utterly illogical? Because if the universe truly contains countless stars spread in every direction, then the entire night sky should be ablaze with light, thanks to the combined light from trillions upon trillions of stars continuously layering upon each other. That scene should be like looking directly at the surface of the sun, but from all directions at once. So, night shouldn't exist, should it? The entire sky should be brilliantly lit by starlight, 24 hours a day. Do you realize how perplexing this is? This isn't merely a minor astronomical curiosity. It's a fundamental contradiction between what we believe about the universe and the reality we witness every night. For centuries, even the most brilliant astronomers have grappled with this perplexing question. Some call it Olbers Paradox, named after a German scientist who clearly articulated the problem in the 19th century. Did you know this problem was actually recognized by many others even before him? And here's what I want you to understand. When we finally uncover the solution to this question together, it won't just be a clever explanation to solve a dry mathematical puzzle. Instead, it will reveal a profoundly fundamental truth about the true nature of the universe we inhabit. It will unveil the secrets of time, space, and even the very origin of this universe. This will force us to completely redefine the meaning of infinity and the true meaning of something having a beginning. Do you think the night sky is merely a beautiful picture to behold? The truth is, in reality, it's trying to convey a message, screaming a profound truth about this universe. What's surprising is that for most of human history, we didn't even realize there was an important question to be asked. We've walked beneath countless stars, written poetry praising the night, but have we ever truly paused to ponder? But wait, shouldn't things be different? This pervasive darkness, is it truly impossible? Is it a lie the universe is deliberately hiding from us? Or rather, is it a colossal clue we've inadvertently missed all this time? So, are you ready to uncover this mystery with me? Because I assure you, this solution will completely change the way you gaze at every starry night for the rest of your life. Ready? Let's embark on a fascinating thought experiment that I'm very fond of. And trust me, this will be an incredibly captivating journey. Because we'll discover that mathematics, when genuinely applied to the universe, can lead to utterly astonishing, even frightening conclusions. Can you imagine yourself floating in vast space, with the entire universe spread out before you? Have you ever tried to visualize a colossal sphere with yourself at its center, encompassing all the stars within a certain radius? Have you pictured that scene? Excellent! And now the most interesting part is coming. What if we imagine doubling the radius of that sphere, making it twice as large? So, how would the surface area of that sphere change? Don't worry, this is just some basic geometry we need to understand. The fact is, when the radius doubles, the surface area of the sphere increases fourfold. This is an immutable law of geometry. Area always increases by the square of the radius. This is not a hypothesis, but an undeniable geometric truth. So, if our universe were uniformly distributed with stars, would that larger sphere contain more stars? Absolutely, it would contain 4 times the number of stars because its area is 4 times larger. But here's the surprising crux. Each individual star within that larger sphere is now twice as far from us. And that means each star will appear 4 times dimmer. This is because light diminishes by the square of the distance, an unchangeable law of physics. In summary, we have 4 times the number of stars. However, each star is 4 times dimmer, and these two factors perfectly cancel each other out. The astonishing thing is that the total amount of light we receive from that spherical shell remains completely constant, no matter how far away it is. Do you grasp the profound implication of this? Let's continue to expand on this idea. What if we double the radius again? Again, there are 4 times as many stars, but each star is 4 times dimmer. Do you notice that each object possesses the same total brightness, repeating endlessly? What if each spherical shell we add, regardless of distance, contributes the exact same amount of light to the night sky? Brace yourself, because this is where it gets truly terrifying. Have you ever wondered, if the universe is infinite in space, has existed for an infinite amount of time, and is uniformly filled with stars in all directions, wouldn't we have an infinite number of such spherical shells? So where does that lead? These infinite equal contributions of light would sum up to an infinite amount of light. Why is that? Because any non-zero value, when added an infinite number of times, will always result in an infinite outcome. So, what is the mathematical conclusion drawn from this? It is inevitable, irreversible, and chillingly ruthless in its logic. Can you imagine that every line of sight you follow in space will eventually have to end on the surface of a star? No matter where you look, up, down, left, right, or any imaginable direction, your line of sight will eventually intersect a star. What does this mean? To visualize it easily, imagine you are standing in the middle of an infinite forest. If trees are uniformly distributed throughout, and the forest is truly infinite, then no matter which way you look, your line of sight will eventually hit a tree trunk. Do you agree? Absolutely no gaps. That would be completely impossible. Therefore, our night sky should not have dark patches. It cannot be a black velvet adorned with sparkling dots. Does this confuse you? Instead, the entire sky should be as bright as the surface of the sun in every direction, or we would be engulfed in starlight, day and night, scorched by incessant radiation. Can you imagine that? In that case, Earth would turn into a giant furnace and life would be impossible. Isn't that terrifying? Can you imagine how 19th century astronomers, when they finally sat down to do these calculations, must have felt a chill to their very bones? Why did they shiver? Because mathematics is always perfect, unforgiving, and never makes mistakes in its calculations. Yet, paradoxically, when they stepped outside at night and looked up, what did they see? Enveloping darkness. A beautiful, glorious darkness, but one that, according to mathematical logic, could not exist. Does this make you think? Who popularized this perplexing paradox? It was Heinrich Olbers in 1823, although Edmund Halley and others had pondered the idea before. But what made Olbers' discovery so special? It was his presentation that captured the scientific imagination, turning it into one of astronomy's greatest mysteries. So, what challenging questions does Olbers' paradox pose? It forces us to confront one of the following possibilities. Either there's a fundamental flaw in our thinking, or the universe is not infinite, not eternal, not uniformly filled with stars, or we are overlooking a crucial factor. What is happening when mathematics seems to be screaming at us that our fundamental understanding of the universe has a giant hole? And it is at this point, my friends, that science truly becomes fascinating and dramatic. When faced with such a perplexing paradox, what should we do? Well, the reaction of every good scientist is the same. We start looking for explanations. And here's an interesting thing about the scientific journey that you might not know. Wrong answers sometimes teach us more valuable lessons, even more than the right answers. What was the first explanation given, which sounded perfectly reasonable? Oh, right, there must be interstellar dust absorbing light from distant stars, and that's why the night sky is dark. Upon hearing this, you might exclaim, "Oh, that makes perfect sense. We know there's interstellar dust, and dust blocks light. So the problem is solved." But wait, let's think a bit more deeply. What actually happens when dust absorbs light? It heats up. That's a basic principle of physics. Energy cannot simply disappear. And if all that enormous amount of dust continuously absorbs light from countless stars over an infinite period, what do you think would happen? It would heat up, getting hotter and hotter until it reached a temperature equivalent to the surface of the stars themselves. So, once the dust is glowing hot like that, what would it do? It would emit its own light, releasing all the absorbed energy. Thus, we wouldn't have solved anything. We would have merely changed the light source. Instead of directly seeing the stars, we would see glowing clouds of dust. As a result, the night sky would still be as bright as day. Imagine it this way. It's like placing a filter in front of a perpetually burning lamp. And eventually, that very filter would become a light source itself. A beautiful mistake, isn't it? It shows the complexity of the universe. In fact, it taught us a profound lesson about the law of conservation of energy and thermal equilibrium. So, if the first explanation isn't correct, what's the second hypothesis? What if stars aren't uniformly distributed throughout the universe? Instead, they tend to cluster together in groups. And between these groups are vast voids, regions of nearly empty space. Could this be the reason for the darkness of the night sky? It sounds plausible, doesn't it? Don't we all know that stars form galaxies? And then these galaxies gather into larger clusters? However, the real problem lies here. This explanation merely pushes the problem further away. If the universe is truly infinite, then how you arrange your group stars together becomes meaningless. Your gaze, sooner or later, will always land on a star. Imagine you're lost in an endless forest. No matter how chaotically or sparsely the trees grow, if you walk straight in any direction, you're bound to hit a tree trunk, aren't you? Although uneven distribution might create patches of light and dark in the sky, fundamentally, it cannot make the entire sky dark. And now let's move on to the explanation I find most compelling. The third explanation, though it sounds incredibly sophisticated and convincing. But according to Einstein's theory of general relativity, gravity can curve space-time, and light, when bent, would disappear into space, unable to reach us. Could that be the reason? When I first heard this, I secretly thought, wow, this person must really know their Einstein. However, that's not how it actually works. Einstein's theory of general relativity actually states that mass curves space and light travels along those curves. But the bending of space-time doesn't mean light disappears or is lost. It simply follows curved paths. And in a static infinite universe, where matter is uniformly distributed everywhere, did you know that not even those average curvatures could save us from the glow? Light, in any case, would find its way to our eyes from every corner. So here they are. 3 explanations as beautiful as they are elegant, each one based on the purest physics. But what if? And all of them incorrect! But why am I revealing all this to you? Because what these erroneous answers reveal to us is quite simply astonishing. They all start from one absolutely fundamental assumption, that the cosmos is immutable, limitless, and perpetual. That it has always existed and always will exist. That its essence remains unchangeable through time. And that's precisely where the true dilemma, the central paradox, lies. Olbers Paradox in reality isn't about stars, light, or dust. It's about our most deeply ingrained assumptions about the very essence of the universe. To unravel this curious paradox, will we be ready to give up one or more of those ideas that seem so undeniably true to us? Do you realize how this story is unfolding? The darkness of the night sky is revealing a revolutionary secret to us. Something that will change our understanding of the essential nature of the cosmos. And now, are you ready to discover what exactly that is? What then is the first great secret that darkness entrusts to us? A truth that when spoken seems so obvious, yet transforms absolutely everything. Light does not travel instantaneously. Do you know how fast it travels? Yes, exactly 300,000 kilometers per second, a mind-boggling number. However, a little-known fact, that speed is not infinite. And this, my friends, carries a profoundly deep meaning. When you look up at a star in the night sky, are you truly seeing it in the present moment? No, you are witnessing its image from the moment that light began its journey away from it. Suppose you are gazing at Alpha Centauri, our closest star to the Sun. You are actually seeing its image from 4 years ago, all because the light from that star took that long to travel through space and reach your eyes. A journey lasting 4 years, traversing vast empty space. Take a moment to ponder this and really truly think about it. What if that star had exploded 3 years ago, yet we would still see it shining peacefully tonight, while completely unaware that, in reality, it no longer exists? Now, let's expand this thought to a larger perspective. Can you imagine that there are stars thousands of light years away from us, and even millions of light years away? When we turn our gaze towards the distant Andromeda galaxy, what awaits us? We are seeing light that left it 2.5 million years ago, an astonishing glimpse through time. Have you ever wondered, from ancient times when our ancestors first tentatively crafted stone tools in Africa, but what is truly the crux, the most crucial factor, a truth capable of completely changing how we perceive this paradox? What if our universe only has a finite age? More specifically, according to our current understanding, about 14 billion years. In that case, we can only observe light emitted from celestial bodies. Those celestial bodies that are close enough for their light to have traveled to Earth. Are you aware of a limit, a cosmic horizon that we cannot cross? Beyond a certain distance threshold, light from there simply hasn't had enough time to reach us. Does the number of stars out there still matter if their light is still on its way? We cannot see them, and the night sky is dark because we are observing a universe with a formation history, a universe with an age. Not because there are too few stars, but because we are only able to observe a finite portion of the entire universe. And you want to know the wonder hidden behind this truth? The very darkness of the night sky is direct, undeniable proof that the universe once had a beginning. If the universe had an infinite age, then all that light would have had infinite time to reach us by now, but clearly that hasn't happened. The darkness of the night is screaming a clear message. Our universe has a history, that there was once a moment, a starting point for all things. But wait, the story doesn't end there. There's much more excitement to come. Have you ever wondered if our universe is a static entity, or if it's constantly moving and changing? In the 1920s, a great scientist named Edwin Hubble, with the help of the most powerful telescope of his time, unveiled a truth that astonished the entire world. Can you imagine that all the galaxies we observe are constantly moving away from us? What's even more astonishing is that the greater the distance, the faster they recede. This proves one thing: our universe is not static. On the contrary, it is constantly expanding. And this expansion adds a second crucial aspect to how we interpret the universe. Did you know that when a luminous object moves extremely fast away from you, the light it emits gets stretched? This phenomenon is similar to the Doppler effect you often hear when an ambulance rushes past you. As the ambulance moves away, its sound becomes lower in pitch, right? And something similarly incredible happens with light. When a galaxy recedes, the light it emits gets stretched, shifting towards longer wavelengths. As a result, we see it as redder. This fascinating phenomenon is called redshift by astronomers. Can you imagine that the farthest galaxies, moving fastest due to the expansion of space, have been redshifted to the point where their visible light has turned into infrared light? That is a type of light that our eyes cannot see at all. Technically, that light still exists, but it has become too faint and stretched to be almost invisible to our vision. Amazingly, the expansion of the universe is actually dimming the most distant light sources, causing them to gradually disappear from our sight. Thus, we now have two solid reasons to refute Olbers' idea of a brightly lit night sky. Have you ever wondered what limits our view of the universe? A universe of finite age has created a cosmic horizon, and its continuous expansion weakens and redshifts light from the most distant sources. And what happens when these two factors combine? Together, they obscure our vision, keeping us in a mysterious darkness. But did you know there's still one more mysterious piece? Perhaps the most fascinating one we haven't yet discovered. This final piece is truly extraordinary, so much so that no great thinker in history could have ever imagined it. Can you believe that the very darkness that blankets the night sky is direct, undeniable proof that our universe once had a beginning? Hello, join me as we explore why this truth is so astonishing. Did you know that at the time? When Albert Olbers published his famous paradox in 1823, most people back then believed the universe was eternal, infinite in space, and had no beginning or end in time. That was considered self-evident truth. But would you be surprised to learn that truth was completely wrong? And astonishingly, the evidence for this truth was right above their heads every night, just waiting to be discovered if they knew how to look at it correctly. So what is the full truth? Our universe, according to estimates, is only about 13.8 billion years old. That sounds like a huge number, and it is for a human lifetime. But did you know that, for the universe, this is just a finite and limited period? And this very finiteness has completely changed the way we perceive everything. Did you know that even though light travels incredibly fast, it's not instantaneous? At a speed of 300,000 kilometers per second, that is the absolute limit that nothing can surpass. Indeed, nothing in this universe can travel faster than that speed. So now, let's ponder this. If the universe has only existed for 13.8 billion years, does that mean we can only observe light from objects a maximum of 13.8 billion light years away, right? Can you imagine? That is our cosmic horizon? Although countless stars might exist even further away, why don't we see them? Simply because their light hasn't had time to reach us yet. Can you feel the wonder hidden in this? The surprising thing is, the dark night sky isn't due to a lack of stars, but because time itself has a certain limit. But wait, what's coming next will amaze you even more. Imagine this. Even if the universe were infinite in space and filled with countless stars, if it were still too young, the sky would remain dark. Why is that? It is the finite age of the universe itself that has unveiled the mystery of Olbers Paradox. Could it be that time has acted as a guardian, shielding us from a sky so brilliantly dazzling that we once feared it? And what is the most ironic, yet beautiful, thing in this entire story, do you know? For centuries, astronomers diligently pointed their telescopes at the sky, eager to find a solution to Olbers' paradox. They catalogued stars, measured distances, studied nebulae. But to what avail? Yet the answer didn't come from looking further or from possessing more advanced telescopes. Where did it come from then? From physicists who sat down and deeply contemplated the nature of time, the expansion of space, and the origin of the universe. So where does the solution lie? Not in the stars we can observe, but in time itself, something we cannot directly see. Every time you gaze up at the vast night sky, do you know what you're witnessing? It is the powerful evidence of the Big Bang. This is not a metaphor, nor flowery poetry, even though this truth is breathtakingly beautiful. That is a self-evident truth, literally. Can you hear it? The darkness between those stars is whispering something profoundly fundamental about the nature of reality to you. Our universe, it once had a beginning, and that moment occurred nearly 14 billion years ago, when everything began to take shape. Did you know that the real evidence is hidden right within the darkness we've long overlooked? In fact, this is not an unusual phenomenon at all. For centuries, a great question has troubled humanity. Why is the night sky dark when the universe contains countless brilliant stars? Surprisingly, this seemingly unanswerable question holds its own solution within itself. The precise reason why the night sky is dark is because our universe has only existed for a finite period since everything began. So the darkness we see is the clearest manifestation of time. So the next time you step outside on a clear night and look up, don't just get lost in admiring the twinkling stars, but try to contemplate the deep black void hidden between them. That darkness is not an empty, bland, or meaningless void. It's not merely the absence of light, as we often think. Instead, it is a powerful sign, a testament to the birth of the entire universe. It is undeniable proof that we exist in a universe with a clear formation history, a specific beginning, and perhaps even a predetermined future. Do you realize? That very darkness is whispering to you the greatest story. A story never fully explored, the story of the nature of time. And that marvel, my friends, is far more beautiful and captivating than any brilliant and serene sky that astronomer Olbers ever imagined in his hypothesis. Amazingly, darkness turns out to be one of the richest sources of information we can observe and explore. Who would have thought that simply by looking into the infinite void, we could learn so many profound things about this vast universe?